This is College Algebra, Northern Oklahoma College, Math 1513. I'm on chapter 1.3, and we're working an example for problem number 51. We're doing quadratic equations solved using the quadratic formula. Now, we've learned lots of ways. We learned solving by factoring and using the zero product principle. We've learned by square root procedure. We've learned by completing the square. We've learned all these methods of solving quadratic equations. This is the last one I'm going to teach you, and the reason it's last is because it's a last resort. I always tell my students the quadratic formula always works. It always works. It's just a hassle to deal with, and it's just so easy to make a mistake on it because we have so many things going on here. So if you find a quadratic equation you can't solve, definitely use the quadratic formula, but only as a last resort. Try and use one of those easier methods first. All right, the quadratic formula, I think everybody has seen this before, and some of you even have a song you sing to remember it. Make sure you put this on your little note card for your test. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'll tell you what a, b, and c are in a minute. Something I want to add to this, I think everybody's seen this, but something I want to add that I tell all my students is to put parentheses around every letter, because we're getting ready to take those letters out and put numbers in, and you're less likely to make a mistake if you write this formula with parentheses around the letter, because we're getting ready to take A and B and C out and put numbers in for them. So that's my my hint. First of all, what are the A and B and C we were talking about? I told you I'd tell you. The A is the number in front of the x squared, and the B is the number in front of the x, and the C is the constant, the regular whole number. All right, there's your A, B, and C. Here's what it looks like in a real equation. All right, here's an example of an equation. Your A is the number in front of your x squared. So what is in front of my x squared? If you don't see something, it's a 1, because there is an x squared there. It's not a 0. We do have an x squared. It's a 1. So we say A equals 1. Now B is your number in front of the x. And here's what people mess up a lot. They think it's 5. It's actually negative 5. See that minus sign in front of it? That's a B is a negative 5. And by the same token, your number out here on the end is your C. And it's not a 24. It's a negative 24. So you have to be careful about that. Okay, that example actually came from your example 51. Here's how example 51 started. X squared minus 5x equals 24. Don't worry about that gap there. We're not completing the square. I just left a gap there so everything would line up. The important thing about quadratic equation is, quadratic formula, it has to equal 0 before you can use your A's and B's and C's. So we need to make this thing equal 0. We need to get rid of 24 on both sides. And now we have x squared minus 5x minus 24 equals 0, just like in the example. So you know what your A and your B and your C are. All right, so we're ready to go. We know what our A, our B, and our C are. And I have the quadratic formula written down. I have parentheses around my A's and B's and C's, and I'm ready to start substituting. So I'm going to take letters out and put in numbers. Now I'm just going to do it a piece at a time here. X equals, I need a negative sign, I need a parentheses, and inside the parentheses I'm going to put my B, which happens to be a negative number. That's why I recommend using the parentheses around the letters, because these negative numbers will mess up our answer if we're not careful. Next we have plus or minus. I start my square root symbol. And in parentheses, I have my B, which is negative 5. And the formula says to square that, so I put a little square outside the parentheses, just like it is in the original formula. Minus 4, open parentheses, and I want to put an A in the first parentheses and a C in the second parentheses. My A is the number 1, my C is the negative 24. And this is all over 2. And in parentheses, I take out the A and put in a 1. All right, here's what I do on the next step, and this is a good note to put on your note card for the test. I do 3 things. I simplify this negative negative up front. It won't always be negative negative, but in this case it is. I simplify the 2 times whatever on the bottom, and I simplify what's under the square root. I do those 3 things on the first step. And here's what I get. The negative, negative 5. Remember, two negatives make a positive. So that's really just a positive 5, which I write without parentheses. Next, underneath the parentheses, underneath the square root symbol, excuse me, underneath the square root symbol, I do all of that on my calculator. That's what I recommend. So starting with this parentheses right here, starting with that parentheses, put that all in your calculator. Now, not the square root symbol. Don't put the square root symbol in. Just put in everything under the square root and let your calculator simplify that number. In this case, it's 121. So you might practice, you might stop the video right now and practice and see if you can get this right here under the square root symbol. See if you can get that to equal 121. The square root symbol is still there. That's going to be step 2. So step 1 is simplify the 5. So I simplified the 5. I simplified the number under the root, and I hadn't done this yet. I simplified the number on the bottom. 2 times 1 is 2. So step 1 is simplify those 3 things. All right, for step 2, my next step, I am going to simplify that square root as best I can. Now in this case, for this first example, they gave you a nice easy one because square root of 121 is a perfect square. Its square root is the number 11. So I simplify square root of 121 to 11, and my final step is to split into 2 situations. So I have 5 plus 11 over 2, or this is how I get my 2 answers. X equals 5 minus 11 over 2. So let's simplify both of those. Remember, when you're doing fractions, get the top down to one number and the bottom down to one number before you divide. Get the top down to one number and get the bottom down to one number before you divide. And we finish it off. X equals 8 or x equals negative 3. Like I said, not a difficult process, just lots of pieces to it, and it's easy to make a mistake if you're not careful. All right, here's an example for number 55. I'm going to go a little faster now since we know the procedure. First, we need to know what our A and B and C are. So let's label those. So A is in front of the x squared. It's a 1. So A equals 1, B equals 4, C equals negative 1. They always go in that order. Your x squared number, then your x number, then your constant. Then write your formula. Make sure to add the parentheses around the letters. I know you guys are going to fight me on this, but these negative numbers, when you insert those, they're going to mess you up if you don't use parentheses. All right, so this time I wrote it a little bit differently. I put all the parentheses in where the letters are. You know, I took all the letters out, put the parentheses there, and it might be a little clearer for you about what goes where. So right here, in my first parentheses, that's a B, so I put in a 4. And this parentheses that's being squared, that's a B also, so I put a 4 inside that. And then we have an A and a C, so I put in a 1 and a negative 1. Use the parentheses. That negative 1 is going to mess you up. And on bottom I have 2 times A, so that's 2 times 1. Okay, remember what I do. I do 3 things in one step. I simplify this. Sometimes it's a negative negative. I simplify what's under the square root. I don't take the square root yet. We're going to do that on the next step. Just plug all of this in, starting with the parentheses. Plug all of that into your calculator and let it simplify it to a single number for you. And then I do that number on bottom as well. So I do those 3 things on my first step. And I get x equals negative 4, okay, because this time it's just one negative in front of it, so it really is negative 4. My number under the square root is 20, and on bottom 2 times 1 is 2. All right, now eventually I'm going to have to split this into 2 fractions because this one isn't going to clean up real nicely. And you can do it pretty much, you can wait till the end and do it, but I'm going to go ahead and do it now. I'm going to split it back into 2 separate fractions with a denominator of 2. And we'll simplify each fraction individually. We can put it back together later if we want to, but sometimes it's easier if you split it into 2 fractions and simplify. All right, let's simplify. We got negative 2, all right, plus or minus. Now the square root of 20, that's a big square root. I bet there's a perfect square hiding inside of there. So I do my 2 square roots and I look for that perfect square hiding inside. There is a perfect square. Radical 4 times radical 5. Square root of 4 is going to be a perfect square. So I break that 20 into 4 times 5 because square root of 4 is going to turn into a 2 in a second. And there it is, x equals negative 2 plus or minus 2 radical 5 over 2. Now look at this part of the fraction right here, the whole numbers. Don't look at the square root, look at the whole numbers. That's 2 over 2. 2 divided by 2 is simply a 1. So we have negative 2 plus or minus 1 square root of 5. And you know what? We don't need that 1 right there, so I'm just going to leave it off. So we have negative 2 plus or minus square root of 5. Okay, there's lots wrong with this equation. It's an example for number 59. I don't have it equal to 0, and my x squared is negative, so I'm going to take care of all of that at once. I'm going to move that x squared term over to the other side so it becomes a positive x squared because they're easier to deal with. And I'm going to move the 9 at the same time so that I have a 0 on the right. And I end up with this, 2x plus 3x squared minus 9 equals 0. I'm not quite ready because I need it to be in the right order. I need the x squared term first, and then the x, and then the 9. And remember, wherever you move them, their signs go with them. So that's the order I want them in. Just make sure that their sign went with them. The 3x squared moved to the front. It was positive. It's still positive. 2x was positive up here. It's still positive. We'll call that plus 2x. Same thing. And 9 was negative up there. It's still negative. We'll call it minus 9. So everything's good. So a equals 3, b equals 2, and c equals negative 9. Watch that negative. And here's our substitution. Remember, I'm going to do this, and this, and this on the next step. And I get this. Next, I'm going to see if I can simplify that square root. Now this one I had to actually work a little bit because there is a square root in there. It's just not obvious. 16 will go into it, and 16 is a perfect square. So change 112 to 16 times 7. And we get negative 2 plus or minus 4 because square root of 16 is 4. Square root of 7 over 6. And like I said, it makes more sense to most students if we go ahead and split it into 2 fractions at this point and simplify each one individually. Just seems like they get the answer right more often when we do this. We can put it back together later into 1 fraction. So my negative 2 over 6 reduces to negative 1 over 3. And then if I just look at the integer part here, the 4 over 6, that reduces to 2 over 3. Now like I said, we can put it back together later. So let's go ahead and put it back into 1 fraction. And that's what we get. Negative 1 plus or minus 2 radical 7 over 3. Remember, the whole number comes first, square root comes second. That's good grammar. Okay, an example for number 67. I've done most of it already. You guys should know all this. You knew they were going to throw some imaginary numbers at you, so here it is. Here's my substitution. On the next step, I'm going to do this, and this, and this. That's what's on the next step. So I got negative 6, and there's my imaginary number, square root of negative 48. It's getting ready to be imaginary, over 2. And I did a whole lot on this step. I went ahead and split it into 2 fractions, because I usually do anyway. And I split the square root of negative 48 into square root of negative 1. That's going to be our I. Square root of 16, because it's a perfect square, it's going to turn into 4. And that's kind of our leftover square root of 3. So let's simplify. And I get negative 3 plus or minus I times 4 times square root of 3 all over 2. Let's make it look a little nicer. Okay, so to clean it up a little bit, just looking at this term right here, that's imaginary. It never comes first. We always like the real number to come first. And then it's kind of a toss-up between the square root and the I coming next. But what most people do is they use the whole number, 4, and then the imaginary, and then the square root. If there's an order that's preferred, that's it. So a whole number first, you already knew that. Then the I, then the square root. Now, notice the whole numbers will reduce. And that's the cleanest answer I can come up with. Okay, I'm not going to work number 87 for you, but here's a quick hint. You start with your original formula, and then they tell you what the P stands for. But to use the quadratic formula on this, remember that this number needs to be 0. So that's your hint. Okay, subtract 518,000 from both sides, and then continue on. And one final hint on number 99. Here's your original equation. Then they tell you that h is 36. Remember, you need to have a 0, okay? So I would minus 36 from both sides. And while we're at it, I would go ahead and distribute the 1/2